All right, this video is going to be part 3 of transformations. We're going to go over reflections first, and then we're going to go over multiple transformations. Like over here, you see there's multiple transformations on this f of x original parent function. So let's cover reflections first. Reflections are when there's a negative either out in front of f of x or inside f of x. So we'll do out front first. When it is out front, it affects, I didn't want that to be blue. All right, when it's out front, it affects the y. Now, I want you to kind of think about something. Imagine I had a coordinate here at 2, 6. If I was to times by a negative and it affects the y, it would become 2, -6. So it would become a point here. Now, the thing that I'm trying to get you to understand is, yes, it affects the y, but look at what it reflected across. It's a mirror image from here to here across the x-axis. So even though it affects the y, it reflects across the x-axis. That's a really important, sorry, they still have the bells on here at the school. That's a really important thing to understand. So let's look at the other scenario, which would be if it's a negative inside the f of x here. It affects the x. Now, here's an example. Imagine that point 2, 6 again. If I applied a negative to the x, it would become -2, 6. And it would be a point here. So look at what it reflected across, the y-axis this time. So even though it affects the x, it reflects across the y-axis. So like when you name a transformation, if I say, look over here, if I said name all these transformations, this would be a vertical stretch times 2. This would be a shift, and this would be a shift. That wasn't a good example. There's not a negative there. Imagine it said -2, f of x plus 4 minus 1. You would have to be able to name those transformations. So this, you would have to be able to say, oh, that's a reflection across the x-axis. I pretty much guarantee there's going to be a test question about that, about this right here. All right, so let's start doing some of these examples. Okay, if you have a negative that affects the y, it reflects across the x-axis here. Basically, all you want to do in your table is times by -1. So in this table, I'm timesing by -1. That's how I'm going to get these numbers. And when I say I'm timesing by -1, I'm timesing these coordinates by -1. Now when I graph this thing, I'm going to use this is my x and this is my y. Just like before, you use the outermost coordinates and plot the point. And connect the dots, and it looks something like that. So as you can see, every single point reflected across this x-axis here and went to the other side. So now on the second one, the negative is inside the f of x part, so that means it affects the x, which also means it reflects across the y-axis. So in my table, I'm just gonna, since it affects the x, I'm just going to times by -1 here to these coordinates. So it's going to become +1, -1, -3, -5. When you times by -1, it's just a sign change. So when I graph this, I'm going to be using this and this as my xy coordinates. Oh, that's not right. Then connect these dots. And so the blue is the new one, and if you look at it, like for example, this point here reflected across the y-axis and went over here now. So that's how you handle reflections. Now, honestly, the examples that we've been doing in these 3 videos are not very realistic because in reality, they're going to give you a bunch of different transformations to handle. So like, look at this one. This has 3 transformations. That's more of a realistic problem. So first they want me to make a table of this right here. So I'm just going to pick some points, like this point here. Let me do it in a different color. Like this point here, this point here, this point here, and this point here. So in my table, it's going to look like this. Just list out your xy coordinates that you just chose. So it looks like I have -2, 2. I have 0, -2. I have 1, 4. And I have 2, 0. So I'll show you what to do, but this is the table that I'm going to be using when I do these transformations. All right. I'm going to go ahead and copy that table down again twice. That way these problems are ready for me when I get to them. Okay, and also it says just graph the following transformations. I wouldn't do that though. I would graph them, I would do the table, and I would name them. So like this first point here, this 2, or this first transformation here, this 2, that is a vertical stretch times 2. Then I've got a +4 here. That is a horizontal shift. And since it's +4, you do the opposite. So really -4, it's going to go left 4. And then this -1 here is a vertical shift. Down 1. All right, now in your table, I should have done them in a different color. I'll do it in a different color as I go along. In your table, you're going to have to apply these transformations. So since there's multiple, you kind of need to know what order to go in. You're always going to go left to right. So what I mean by that is looking left to right at this equation right here, the first transformation that I see is that 2, this 2 right here. That is a vertical stretch times 2, so I need to, since it's outside, it affects the y, so it's going to go on this side here. And since it affects the y, it tells the truth, so you actually have to do what it says here, times by 2. So now I've got 4, -4, 8, and 0. I just took all these values and I times them by 2. The next transformation that I see is this +4 here. That's inside, so it affects the x. And since it affects the x, everything is opposite. So instead of adding 4, I'm going to subtract 4 to these points here. So And then last but not least would be, sorry, I'm trying to pick a good color for you. Sure, orange. Last but not least is this transformation here, this -1, that's a vertical shift down 1. It's outside, so it affects the y. So it's going to go on this side in my table. So I'm going to do a -1. Since it's affecting the y, it tells the truth, so just do what it says. So I'm going to take these coordinates and I'm going to subtract 1. Now, when I actually go to graph this thing, you always want to use the outermost coordinates. So these guys and these guys right here as your x, y coordinates. So this line, after all these transformations, would look something like this. This graph is really small. It's difficult to do. Then connect the dots, and that would be done with that problem. Yes, it looks kind of weird, but you have to think it got stretched vertically, it got shifted over. Yes, it's going to look weird. Okay, now this second one, I'm still using the same parent function coordinates as before, and now I need to apply my transformations. Well, I've got 3 of them. There's one here, there's one here, and there's one here. So let's go ahead and name them first. This 2 in front is a vertical stretch times 2. Sorry, it's not vertical at all. I'm getting ahead of myself. This 2 right here is inside the f of x, so I immediately know that's horizontal. And it is timesing by 2, so you would think normally that's a stretch, but in reality, since it's horizontal, it's doing the opposite. So it's not timesing by 2, it's timesing by 1/2, aka dividing by 2. So that's actually a compression times 1/2. Same as dividing by 2. Okay, the next one would be this, this +3 right here. That's inside, so I know it's horizontal as well. And since it's plus or minus, it's a shift. You just have to figure out the direction. It's horizontal, so it's lying to you. So instead of adding 3, you're going to subtract 3. That makes it go left. All right, and then lastly would be this, this -2 here. That's outside, so I know it's vertical. And it's a plus or a minus, so it has to be a shift. And vertically, minus makes it go down 2. All right, now in the table, remember you work your way out left to right like this. So the first thing would be the 2 in front circled in blue, this one. It affects the x, so I'm going to put it on my x side here. And normally it looks like it's multiplying by 2, but in your table you have to do the opposite. So multiply by 1/2 or divide by 2, same thing. So now I'm going to have these coordinates. Now the next one would be that +3. This +3 in the middle, that's inside, so it affects the x. So it's going to go on the x side here of my table. And remember, if it's inside, it lies to you. So do the opposite of +3 and do a -3. So in my table, it's going to look like this. And then the last one would be this -2 at the end in green. It's outside, so it affects the y, so I'm going to put it on my y side, and I'm going to do what it says, so -2. Now when I go to graph this, remember I'm using the outermost coordinates. And it would look something like this. All right. Last page. Okay. I'm going to use those same coordinates as before, as previous, those parent function coordinates to start my table. All right, now this first transformation, this 3 in front, is outside, so it's vertical. It is 3 times, so it's telling the truth, and when you time something by 3, you're stretching it. All right, the next transformation would be this negative sign right there. That's a reflection, what we talked about in the beginning of the video. And since it's inside, it affects the x, which makes it reflect across the y-axis. All right, and then the last one would be this -4 at the end. That's outside, so it's vertical. And since it's plus or minus, it's a shift. And it's a -4, which makes it go down 4. Okay, now in my table, left to right, so the green circled 3 comes first. It's outside, so it affects my y, so I'm going to put it on this y side and do what it says. So I'm timesing by 3 here. All right, the next thing would be that orange reflection, this right here. So it's inside, so it affects my x, so I'm going to put it on my x side. And when it comes to a reflection, really it's just a times -1. It's just a sign changer. So in your table, it would look like times -1 on the x side. And then lastly would be that blue circled 4. It's outside, so it affects the y, so I'm going to put it on the y side. And it tells the truth, so do what it says. Subtract 4. Graph it using the outermost coordinates. This one would look something like this. Okay, for these problems down here at the bottom, you're going to be using this equation right here. And they want you to identify A, B, and H, and K. I'll show you how to do that. But let's go ahead and start naming these transformations. So when I look at this problem here, the first transformation I see is this 2 out in front. It's outside, so it's got to be vertical. It's timesing by 2, and when it's outside, you do what it says. So if I time something by 2, I'm stretching it. Now in terms of the A, B, H, and K, if you look, it's in my A slot. So I just go A equals, and since it's vertical, I can just write whatever it is because it tells the truth, so it's a 2. Next would be this +3 inside. That's horizontal because it's inside. And since it's a plus-minus, it's a shift. You just have to figure out direction. Remember, if it's inside, you're going to be doing the opposite. So it's really going to be a -3, so it's going to go left 3. And when you identify A, B, H, and K, it's in your H slot. So basically just change the sign and write what that is. So H would equal, change the sign from a +3 to a -3. Okay, this next problem, the first transformation I see is the negative out in front. That's a reflection. And since it's outside, it affects the y, which makes it reflect across the x-axis. The next transformation I see would be this plus 2 here. It's inside, so it's horizontal. It's a plus minus, which makes it a shift. Then you just have to figure out direction. It's horizontal, so it's lying to you, so do the opposite. So you're really going to do a minus 2, which makes it go left 2. Now it's in your H slot, so just change the sign from plus 2 to minus 2 and go H equals minus 2. The last one would be this minus 5 at the end. It's outside, so it's vertical. It's plus minus, which makes it a shift. And since it's vertical, you do what it says. So it's minusing 5, which makes it go down 5. It's in your K slot. So since it's vertical, you can just write whatever it is. K equals 5. Minus 5, sorry. It's a minus 5. K equals minus 5. Okay, this next problem, the first transformation I see is the 1/2. It's inside, so that makes it horizontal. And when it's horizontal, it's lying to you, so instead of timesing by 1/2, you're actually dividing by 1/2, which is the same thing as multiplying by 2. So that's actually going to be a stretch times 2. And it's in your B slot down here, so basically just write whatever the denominator is, or flip the fraction and write that number, so 2/1 or just 2. B equals 2. Next transformation would be the minus 1 here. It's inside, so it has to be horizontal, and since it's plus or minus, it has to be a shift. Now you do the opposite since it's horizontal, so instead of minus 1, I'm really going to add 1, which makes it go right 1. And it's in the H slot, so just change the sign of it and write H equals, change the sign from a minus 1 to a positive 1. This last one's the plus 5 at the end. It's outside, so it has to be vertical. It's plus or minus, so it has to be a shift. Since it's vertical, it does what it says, so adding 5 would make it go up 5. And then it's in your K slot right there, so that's going to make it just go K equals, and since it's vertical, you can just write whatever it is, so positive 5. Then this last problem here, the first transformation. Okay, real quick, there's students that see this minus 3 and think it's like a minus 3 at the end. No, it is negative 3 times that F. So there's a reflection there and there's a stretch. So first of all, handle the negative. That's a reflection. Since it's outside, it affects the y, which makes it reflect across the x-axis. Now I can handle the 3, and that's 3 times, so it's outside, so it's vertical. It's timesing, so it has to be a stretch or compression. Well, since it's vertical, you do what it says, so timesing by 3 would stretch. And it's in your A slot. So that means A equals, since it's vertical, you can just write what's there, which is a 3. Then the last one would be this minus 1 at the end. It's outside, so it's vertical. It's a plus minus, which makes it a shift. Since it's vertical, you do what it says. Minus 1 makes it go down 1. And it's in your K slot. So just write K equals, and since it's vertical, you can just put whatever's there, negative 1.